Welcome back to Algebra 2. This is Lesson 27, Rational Expressions. So we've talked about ratios before, and we know that a ratio can be written as a fraction. Thus, when we say 3/4, we can call that 3/4, or we can say 3/4. Whenever an algebraic ratio is written in the form of a fraction, such as a/b, or variables over some other term, we call that a rational expression. So this is a ratio, this is a rational expression. And we've been adding rational expressions by using the least common multiple of the denominators as the new denominator. When one of the denominators is a factor that is a sum, such as, let's say ax cubed plus x, or over x plus 3. When one of these denominators is a sum, then the sum is one of the factors of the least common multiple. So let me clarify that by doing an example problem with you and showing you what that looks like. So let's start with 27.1. We have this, and the denominator here is x plus a. So we're not used to doing fractions like this where we have an expression in the denominator, and that looks kind of confusing, but really we're just going to multiply the two denominators together like we normally do. So that means that the least common denominator is going to be x times x plus a. That's all it is. And what we'll do is we'll continue to multiply this fraction by the opposite denominator so that they have the same denominator here. So what we'll do for this problem is we will say 4 over x times x plus a. So 4 times x plus a over x times x plus a. And you can see how this is multiplied by the top and the bottom. We'll bring down our operation, and we'll do the same thing for here. We'll use x times this whole fraction. So we now have 6x, and then that's over x times x plus a. If I can actually write it correctly. So now they have, and I still want to write a plus a. I don't know why I want to keep doing that. All right, so now they both have the same common denominator. So we can add them together, and what we would do in that regard is we would put them all on the same line, like this, and we would put x over x plus a as the denominator. And then we would use our distribution powers and go ahead and distribute here. So that would be 4x. 4 times a would be plus 4a because they're both positive. And then this would be plus 6x. Well, now we have like terms that we can smush or squish together. So that's going to equal 10x plus 4a. All right, you see how that works? And you do not have to distribute the bottom unless there's a need to. You can leave it as is. All right, and that is how we would solve this type of problem where we have an expression as a denominator. So let's do 27.2. Let me clear this out. Let's look at that one. All right, so this problem gives us a little bit more complexity by giving us a whole number. Well, we know to make a whole number a fraction, we just put it over 1. And 1, because 1 times anything as itself, is an invisible denominator. We don't have to use it when we do our calculations here. But we do have to include 6 in our calculations, which means we do have to multiply this number by these other two denominators. So what we're going to do is we're going to say x squared times x plus 4 times 1 is our common denominator. The 1 goes away because it's invisible. So our common denominator ends up being x squared. Actually, what I'm going to do is I'm going to go ahead and just save a step. And I'm going to make one long line. And I'm going to write our common denominator of x squared times x plus 4. That's our common denominator. And you can save that step too by just writing the line. So the first step is to find the common denominator. Okay, that's step 1. And in this case, it's x squared times x plus 4. That's all we did. Okay. Our next step is going to be to multiply by the missing factor. And that's going to be for each term. Okay? So that goes right here. Multiply each term by the missing factor. So what we'll do for x plus 2 is we'll multiply it by the missing factor. Well, x squared times x plus 4. We have x plus 4. We don't have x squared. So let's multiply x squared times x plus 2. So there's our first term completed. Now we bring down our operation. 6 does not have x squared or x plus 4, so we need to multiply 6 times all of that. So we're going to say 6 times x squared times x plus 4. Okay, there's our second term completed. Now we'll pull down our last operation and we will multiply our final term. Well, this one has x squared, but it doesn't have x plus 4. So we're going to multiply 2 times x plus 4. So now they all have the same common denominator. So now our step is to distribute. So we write our long line again, and our common denominator. And there's a reason we don't multiply this just yet. We might be able to factor some things out, but we need to get all of our terms in order to see that. So x squared times x is x cubed. This is going to be 2x squared plus this is going to be 6x cubed, and then this is going to be 24x squared. This is going to be 2x, and this is going to be 8. All right, now we can add our like terms together. So I'm going to move over here so we have plenty of room. I'm going to draw my line. I'm putting my common denominator at the bottom. And now let's see what we can combine. The first thing you want to look for is the highest exponent of your variable. In this case, that's x cubed. So we have a 1x cubed here and a 6x cubed. So if we add those together, we get 7x cubed. And everything is positive, so I feel confident putting the plus sign here. The next thing we have is x squared. I have a 2x squared and a 24x squared. So it's going to be 26x squared is our next term. And cross those out. And then I have a 2x, and then I have an 8. And that's my last two terms. So I was hoping to be able to factor some things out, but we cannot factor anything out because we don't have an x squared in every term, and we don't have an x plus 4 in every term. So therefore, this is the final answer. 7x cubed plus 26x squared plus 2x plus 8 over x squared times x plus 4. All right, so as you multiply each one, or after you multiply each one, then you're going to distribute anything that has to be distributed in the numerator. Then the next step is to do the squish, which is to add like terms. And then if you can, which we weren't able to here, but if you can, then simplify. And that means to reduce or factor as possible. But we weren't able to do that here, so we could only go to the squish. All right, so let's move on to 27.3. This is our last example problem. Do write down all of these steps in your notebook. Well, not this right here, but this right here. These are the steps for any time that we have adding terms or adding fractions together. We find the common denominator, we multiply by the missing factor, we distribute the numerator. If we need to, we squish or add like terms, and then we simplify. Those are always the steps that we use every time. It's just that our numbers are getting more and more complex as we go forward. So we need to know how to handle that complexity. But the steps remain the same. Okay? All right, let's clear this page and go on to our last example problem. And that's 27.3. I'm going to write it for you so it doesn't take as long. All right, so what happens when we have an expression like this where it's extremely complicated here and it looks like that's going to be over our heads to do? It's really not. There's a simple step that you want to do first. And in this instance, the first step is not to find the common denominator. It is, but there's a step before that. We're going to simplify or factor our denominators. And if you think about that, that's something that you already do anyway. Like if you had a problem that was, so you had 2 over 4 plus 3 over 2 plus, I don't know, 7 over 8. You would factor the 8 and you would see that it had 4 and 2 inside of it. And then you would know how to treat these. You know then that you would multiply this by the 2 and this by the 4 and leave this one alone. So you kind of do that already. It's just not spelled out. It's almost intuitive at this point. So we need to break that back out as a separate step before we start finding our common denominator. Because these problems are getting more and more complex, we can't just do that in our heads anymore. So we're going to factor this first. We're going to factor the trinomial. And we should already know how to factor our trinomials. We've already done that. We had that in Algebra 1, and we reviewed it again earlier. So let's factor this trinomial here. We have x plus 2. And when we break this down into 2 sets of parentheses, we get x times x is x squared. All of these are positive, so that leads me to believe that I can put a positive here and a positive here. The factors of 3 are 1 and 2, right? So, oh, I'm sorry, 3 and 1. Why did I think 1 and 2? The factors of 3 are 1 and 3, so we could put a positive 1 here and a positive 3 here. So whenever we multiply, we get 1x, 3x this way, and 1x this way added together. That gives us a 4x. So that's the correct factoring. Now what we see over here is that this has a factor of x plus 1 already over here, and we have x plus 1 over here. So they have a common factor. So we don't need to include x plus 1 a second time. All we need to do is include it that one time. So our common denominator is going to be, let's put our step here, find common denominator. and excuse my handwriting on this thing, it skips sometimes and it doesn't actually do what I'm writing. The pen and this tablet that I'm writing on don't always communicate well to my screen. So now that we have this, our common denominator, in this instance, it's going to be x times x plus 1, because that's here, but we already have it here, so the only thing we need to bring over is x plus 3, right? So you can see how I did that. We didn't do x plus 1 for both times. So I can make my long line, and I could put my common denominator under it. Right? Okay, and now we're going to multiply. So this already has the x plus 1 and the x plus 3, so the only thing that's missing is the x. So we say x times x plus 2. We bring down our operation. And this already has the x and the x plus 1, so all it's missing is x plus 3. All right, so that was fairly straightforward. Now we can distribute, which is our third step. Okay, so let's do that here. So x times x is x squared, and that's going to be 2x. Negative 1 times x, that's going to be minus x, and then that's going to be a negative 3. Now we squish. And that is going to give us we have an x squared, and we have a 2x minus 1x is going to be a positive 1x minus 3. We can actually factor this, I think, or we can try to factor this, and that's something that you can do. This is taking it a little bit further. This is the simplify step. And the book doesn't actually show us this at this point, but it will further down the road. Let's see if we can factor this as a trinomial and see if we can factor something out. You don't have to do this, but this is just taking it a step further. So we know we have x times x, and we know we have a negative here, so that's going to be a negative and a positive. And we have a positive 1x, so that tells me that the 2 is going to be positive because the factors of 3 are 1 and negative 3. So that's going to give us if this is 3 and this is 1, that would end up being a positive 2, not a positive 1. So it tells me we can't factor it. So that was a wasted effort on my part, but that's okay because you want to try and see if you can factor something out. That's okay. And if you can, it's worth it. It's worth the shot, because then you can cross out one of these and simplify a little bit further. So when you end up with a expression where you have x squared x and then a constant, try to factor it out into factor your trinomial into two sets of binomials and see if you can get rid of one of these down here. It's always a good practice to try to simplify if you can. And we'll go into that more as we go further. So don't worry about that so much this time. But anyway, that's all we have for lesson 27, and I'll see you guys in lesson 28.